but you are not able to see us, isn't it? Okay, I hope that her.
I could turn it around like this.
Ah, no problem. Okay, okay.
Yeah.
No, that's better that I can hear you. Okay, dear Santosh, pleased to meet you. My name is Jean-Emmanuel Aubert. I am professor in the University of Toulouse, France. My colleagues have given me the pleasure to propose me as president for your jury, and I have accepted this with a great pleasure. Also today I will have two roles. The first one as president and the second one as a reviewer of your work. I propose that you begin your defense, and I will introduce the various members of the jury after your presentation before the question session. So I will leave the floor to you for a presentation of about 50 minutes.
Okay.
Thank you.
Thank you. Thank you so much. Respected,
yeah, you can start.
Respected reviewers, member of jury, and audience present here and on the online. Good afternoon, all, and welcome to the PhD defense presentation, which entitles Experimental Analysis of Seismic Vulnerability of Earth Masonry Reinforced with Horizontal Band. This work is funded by EDEX under cross-disciplinary program HITS, and the work has been done in collaboration between two research labs, 3SR, which is specialized in engineering field, and AECC research unit, which is specialized in traditional construction and architecture. So the presentation outline for today is, we'll start with the introduction, where I'll talk about the background of the study, the scientific challenge faced in the field, the role of interdisciplinary in this project, followed by the objective of this thesis, which is fulfilled by the multi-scale experimental approach, which is classified into three different categories, and finally the results and the conclusion and the contribution of this work will be highlighted. Earth construction is one of the oldest construction technique that is still providing shelter to millions of people around the world. And this type of construction is more common in developing and least developed countries, which also lies in seismically active zone, making them seismically vulnerable to earthquake event. Every year, thousands of lives are lost during seismic event, but actually it is not the earthquake that takes life, rather the building which fails to withstand the seismic load and get collapsed, that takes life. So what happens during the seismic event? During a seismic event, there is a horizontal force acting in the structures, creating different stress scenario for in-plane and out-of-plane wall. And in order to prevent this damage, this effect has to be minimized. There are different approaches available for strengthening the unreinforced masonry structures and minimizing the effect of seismic action. And one of them is horizontal seismic band, which is studied in this thesis. So what is horizontal seismic band? In literature, the exact definition was not available, so we have tried to define a horizontal seismic band as a constructive device, which is specific for traditional masonry construction that can be continuous or discontinuous, depending upon the position of application. And this technique is not new. It has been used for more than 5,000 years now. And still we see the application of such a band with a different material around the world. But the documentation of application of such band in guideline and building code is relatively new. It's been 4 decades now, and there are different guidelines which propose and recommend the application of horizontal seismic band in the building code. But among this code, there's a variations in terms of dimension, material used, placement of the band, and it also lacks quantified information regarding how the different material behaves in case of seismic action, which makes it challenging in order to recommend in the field. And in my study, the area of focus is Nepal, so I have referred DUDBC guideline, which is based on the National Building Code of Nepal, National Building Code 203 of Nepal. Nepal lies in a seismically active zone because of presence of two tectonic plates, and because of the difficult terrain, it's very difficult for the road transportations. And due to the seismic event in 2015, there were thousands of structures that was completely collapsed. And as a support from the international organization, AECC and Qatar was involved in the reconstruction activity in Nepal, along with the collaboration of local partner ASF Nepal. During this reconstruction activity, they provided technical support and the training to the local community. But not all houses were properly monitored, and people were seen applying different type of ban in the same structure without following the guideline that was provided by the DDBC, which created a challenging question regarding what could happen in case of future earthquake. Because of the active seismic plate, it's only a matter of time when it will occur, but definitely we have to make sure these structures are safe from the future earthquake. And in the field during the reconstruction, there were various stakeholders involved, and they were not able to address the concern regarding the selection of material, whether it should be used with the timber or with the reinforced concrete, and what could be their performance in case of future earthquake. So in order to address these challenging questions and the request from the stakeholders, AECC took the responsibility to collect the relevant information from site and collaborated with CSR Lab in order to study this behavior scientifically. So in global framework of interdisciplinary, my project PhD research work plays a small role in addressing the scientific challenge that is faced in the field, and provide the scientific recommendation for the community and the various stakeholders, which will be later shared among various stakeholders to implement in the site, and also get feedback from the community in order to what should be the further research work that has to be carried out in order to address the issue in the field. Even in the core PhD research work, there is the involvement of various engineers and architects, which helped in planning the experiment, designing the setup, and execution of all the experimental work. Now, looking at the state of art that has been done in case of seismic band, the mechanical performance of seismic band has been studied in quasi-static and dynamic tests, but there are only few research work which highlights the advantage of having horizontal seismic band in the structures, and there lacks the comparison between different materials when used as a seismic band. And also in the numerical analysis, there is only a few numerical analysis that has been made, and there lacks proper validations from there is a lack of proper validations from the experimental work.
No problem, continue.
Okay.
That doesn't matter.
Okay. So to address this gap in the literature, the objective of my thesis is defined. So the main objective is to study the parasitic behavior of horizontal seismic band and compare the result of two materials when used as a seismic band, one timber, another reinforced concrete. This project is a part of global work, which is classified into experimental and the numerical one. My work is mainly focused for the experimental work, and there was another parallel PhD who developed a numerical model for masonry structures, who completed recently, a few months back. And my experimental result was used for the validation of his numerical model. To achieve the goal of my project, we have divided into three different scales of experimental campaign. Scale 1 at material, where the mechanical property of material and the shear resistance at interface is studied. At scale 2, the characterization of the wall is made with regard to capacity, ductility, and the shear resistance. At scale 3, reduced scale house is tested on the dynamic load and compared their performance. But before moving ahead with exploring the result, let me walk you through the timeline of my PhD journey. Since the beginning of 2018, I was involved in development of two experimental setups, shake table and the shear setup. I spent more than 1 year to develop these two setups along with another PhD student. And I also had developed constructed samples to be tested on the shake table and with the shear test apparatus. But there was a fire incident in 2020 February, which destroyed everything, both the apparatus that was developed was destroyed, and all my samples were completely gone. So there was no any result available. So in order to continue my work, we had to redesign and reorganize all the experimental champion. So in order to continue my PhD work, we had to design a new experimental setup, reaction frame setup, to continue work at 3SR Lab. And we are really thankful for FCBA for providing us the opportunity to use their SIG table for the dynamic test. And due to several reasons, there were no other option rather than choosing extruded adobe for our reduced scale model. But this also provides us the opportunity to compare two type of material, adobe and extruded adobe, which is compared during the study. And it was very challenging period due to the pandemic and a lot of event that was ongoing. So it was very challenging task to be completed in short time of period. So now let's move ahead with exploring the results for material scale. So 3 type of test is carried out to measure the compressive flexure and the shear strength of the material. This test is important because during an earthquake event, the structures goes under different stress scenario, creating different stress mode, and this stress can govern the overall behavior of the structures. And the 2 type of brick unit is used, one adobe, which is standard size, and for the extruded adobe, we have customized for our reduced scale model. And there are 2 type of mortar, that is one used for along with the adobe brick, another with extruded adobe brick. For the compression test, the adobe brick is tested under the vertical orientation without having any interface on the surface, and the two mortar composition is tested with cylindrical samples. And the difference in the compressive strength is due to the composition of the material and the manufacturing process. Similarly, the flexural test is carried out with the 3-point bending test, and the maximum force at failure is used to calculate the flexural strength. As the failure is from the bottom part of the brick, which is brittle in nature, and so the flexural strength can be equivalent to the tensile strength of the brick unit. Another test was done with a sandwich sample. So we tested by fixing one of the brick and applying load on the other brick in order to determine what is the shear resistance. This technique can be also used while optimizing the composition of mortar, which is very relevant in the field applications as well. Here we can see the value for extruded brick is lower as compared to adobe because of the surface rugosity of the brick unit itself. Next, 5 wall samples were prepared, 3 with adobe brick, 2 with extruded adobe brick, and the dimension of this wall was inspired from the previous research work. And we have like on the bottom and on the top, we have a concrete part which is used as a support and as a load application. All the samples were prepared with a random speckle patterns in order to carry out the digital image correlations, and the result obtained from the measurement sensors and digital image correlation is analyzed. So as mentioned earlier in the timeline, we had developed everything for the quasi-static test, but unfortunately fire destroyed everything. And to continue the work, we developed another setup, reaction frame setup, which is driven by electrical jack of capacity 40 kilonewton, and the 4 bar indicated as T1 to T4 is used to apply the initial pre-compression load on the sample, which helps also to prevent the initial rocking moment and transfer the shear force in the shear plane. And all the tests were carried out in displacement control mode, and the same loading was applied for each wall. So let's look at one of the video of the test. So here we can see the load is applied on the top part, and we have a force sensors measuring the applied force, and there is a 2 LVDT attached at the bottom and at the top measuring the relative displacement, which is used for further analysis. So the result from the force cell and the relative displacement is used to obtain the hysteresis curve, and the red line indicates the curve envelope, which is used for further other analysis as well. Here we can see with the application of seismic band, both peak force and the corresponding displacement is increased. Similarly, for extruded brick also we observe higher value for the peak force and the corresponding displacement. That means with the application of seismic band, both this parameter of the peak force and the displacement capacity is enhanced. Next, for calculation of modulus of rigidity, the same curve envelope is used to obtain the shear stress strain curve, and the second modulus is calculated at the maximum level in both directions, in the positive and the negative loading direction, and the mean value is taken for each case, which ranges from 4 to 7 megapascal. Another calculation is made for the stiffness degradation. For this, the stiffness at same level of displacement in both positive and negative direction is used to measure the slope between that 2 points in order to obtain what is the stiffness at each level of loading or displacement limit. And here we can see with the application of seismic band, both the modulus of rigidity and the stiffness degradation rate is modified. Next, in order to characterize the behavior of shear wall, bilinear idealization is made with the help of equivalent energy elastic plastic method. In this method, the failure limit is measured at 80% of peak load in the post-peak phase, and the initial stiffness is measured at 40% of the peak load, which provides the yield force limit taking into account the equivalent energy dissipated until the failure is reached. So bilinear idealization curve is developed for both positive part of the envelope curve and negative part. For both wall, we observe that the capacity and the ductility limit is enhanced with the application of seismic band. Next, energy dissipation is calculated by taking the area under the curve, which accounts for both kinematic and the thermal energy dissipations. And here we see with the application of seismic band, the total energy dissipation is also increased. The next, for calculation of equivalent viscous damping ratio, we have used hysteresis curve, and the energy dissipated per cycle is equivalent to that of viscous damping is the principle which is used for calculation of equivalent viscous damping. Here we have used full cycle approach, and the result is compared for different different configuration of wall. Here we see with the adobe wall we have relatively comparable nature of curve, but with the case of extruded, which is relatively smooth surface, we see significant difference in the viscous damping ratio value. Next, the qualitative analysis of the final crack. Here we see the red box indicates the location where the crack went through the brick unit. It is because of the lower tensile strength of the adobe brick, which created a failure to pass through the brick unit. But with extruded, which has got higher tensile strength, all the failure was at the interface between the mortar and the brick unit in both the cases. Next, with the help of digital image correlations, we are able to understand what is the crack point and the crack propagation path. And here I have compared the result at one of the relative displacement, where we can see with the help of strain field, the strain concentration indicates the location where there is potential chance of crack generation and the path of crack propagation. With the application of seismic band, we can see the number of the concentration point is minimized, and the path of the crack propagation is also modified. Likewise, for extruded brick also, we have measured the stress during different loading cycles, and here I have only taken the two images which was taken at relative displacement of 10. Here we can see with the application of seismic band, the stress path is different, and the seismic band helps also to modify the path of the crack. Next, scale 3 at building. I was involved in developing the SEC table. There were a lot of issues which was tackled and which was resolved, but unfortunately after the fire nothing was available. And we are really thankful for FCBA for providing us opportunity to use their SEC table, and also the financial support from the insurance. And it was really hard work of our entire team during the pandemic, who made successful like all these three house model, which was a real challenge for us. And the capacity of the stack table is very important in order to determine the size of the structure that has to be tested. So in order to design what should be tested on this stack table, we consider the capacity of the stack table available at FCBA photo. And we decided to use half-scale reduced model for 3 different configurations. The dimension of this house was adopted from the DODBC guideline, and a simplified model was chosen in order to compare the behavior of different band materials. And the structure was also made symmetric with the application of 2 windows and 3 doors in order to prevent the torsional effect. All the dimensions of this house was modified as per the Cauchy law, and the earthquake signal that was tested was also modified as per the scaling factors in order to have the same effect on the structures, reducing structures. And finally, the result obtained from the measurement sensors and with the application of DIC has been analyzed. But before moving ahead with the result exploration, let's look at the specimen preparation stage. So 3 houses were prepared, with only difference with the application of band at 4 different levels: sill, intermediate, lintel, and roof. All these houses were prepared simultaneously on the 3 metallic frame. We had help of 5 students for 1 week, master student who helped us to during the construction work, and like all the 3 structures were simultaneously built with the application of mud mortar and extruded Adobe brick. And this structure was left for drying for approximately 3 weeks before we started applying spackle patterns on each surface for digital image correlations. And we also developed a new setup in order to move the sample from the floor level to the table. So here we see the process of moving the sample from the floor onto the table. So after placing the sample on the table, all the measurement sensors were installed and the test was carried. So for each house, we applied 5 different level of loading, starting from the lower to the maximum. This one is at the final stage of loading without band structures. All the structures had 2 types of measurement sensors. Accelerometer was placed on the top of the structures on the corners, and out of plane wall had 7 drawing wires displacement sensor, 5 along the midline of out of plane, and 2 at the corners, 6 and 7 at the corners of the out of plane wall, which is also used for the validation of the digital image correlation. For the imaging setup, we had 2 camera setup, one high-speed camera recording the image of in-plane wall, and another 2 camera for stereo vision system recording the image of out of plane and in-plane both. Here, most of the analysis has been made with the help of image captured using the high-speed camera, which was recording the image at 1,000 frames per second. For global structure response, all the structures were tested with a white noise signal before we start the test. And after each loading cycle was completed, we applied another white noise to measure the difference in the fundamental frequency of the structures, which helps us to indicate what is the extent of damage after each loading cycle. Similarly, the amplification of acceleration was measured, taking the average value of each acceleration measured by the 4 accelerometer placed at the corner of the structures. And here we see, with the help of seismic band, the damage rate is also modified, and we have a lower amplification because of the sliding at the interface between the seismic band and the other unit. Another calculation was made for equivalent viscous damping. For this, half power bandwidth method is used, which takes into account the 2 frequency on the post and the peak value. So here we have compared the average value of equivalent viscous damping, and we find the comparable results for all the 3 structures. The qualitative analysis is shown here after the final loading cycles, and the red box indicates the location where we have a maximum damage. When we compare the two structures with the application of seismic band, we see the damage even after the fifth loading cycle was repairable, and the building was still standing still without having a major influence of getting into complete collapse. Next, for digital image correlation, it is very useful in order to find the displacement field throughout this sample, and we can pick individual points in order to make the analysis. So here I have compared by taking the major principal strain, which also helps us to see how the crack has been generated at different loading cycle and how it has been propagated during the loading cycles. Here we see the crack that was generated in the upper part is moving on the bottom sections without having any band, but with the band, the strain is concentrated at the band level, and it prevents the propagation of the crack from each interband section. Another for hysteresis energy dissipations, I have also used the result obtained from the digital image correlations, and I have taken a right part of the structures and divided into 4 different sections separated with the band level. And for each band level, the force value is calculated taking the average accelerations, and the relative displacement is measured by taking the difference between the top and the bottom part to generate the hysteresis curve for force and the relative displacement. But to understand this hysteresis curve, it is very complicated. So in order to simplify the work, I decided to discretize the result in 1 second time interval, and then the area under the curve is calculated for each time second. So here we plot the cumulative energy dissipations with respect to the relative displacement, cumulative relative displacement, and for each interband sections we have made a calculation for this behavior. And when we compare the result for different interband level sections, where we see with the band level interband level 3 there is a maximum energy dissipation, and with band level 4 we have a least cumulative energy dissipation. It was same for all the 3 structures. And next, it was interesting to see what is the overall behavior of in terms of energy dissipation. For this, I added the energy dissipation at each interband level in order to compare the result for 3 structures. And here we see with the application of seismic band, we have more cumulative energy dissipation. Next, analysis was made for the sliding at the interface. For this also, I have divided the incline wall into 12 components separated by band level and also with the openings. And the sliding at the interface is calculated taking the displacement element. And here we see the maximum displacement is obtained at lintel level, and the minimum is at roof band level, in both cases of timber and RCA band. Next, for outer plane displacement, I have used the data from the drawing wire displacement sensor, and here the result is plotted with respect to the maximum relative displacement that is obtained at the top of the wall. And here with the application of seismic band, the maximum displacement is also reduced at each level. So for the conclusion, I have divided into 2 different parts, for static and dynamic. Here I have compared the peak load capacity for different configurations. Here all the results has been normalized with respect to the wall without band. So with application of timber seismic band, there is 6% higher peak load capacity, and with the use of RC band, we have 29% of increase in the peak load capacity. Similarly, the ductility also is compared with respect to a different configuration, and here we see the ductility also enhanced with the application of seismic band. Next, for energy dissipation also, we have increase in case of energy dissipation with the application of seismic band. For the dynamic test, we have increased in the energy dissipation with the application of seismic band. There is 34% increase with the application of timber, and 46% increase with the application of RC. In both the structures, even after the 5 loading cycles, there were repairable damage and the structure was still standing. So both structures help to control the crack propagations. So the main conclusions from this whole experiment is with the application of seismic band, the seismic characteristics of the structure is enhanced, and both structures with the application of seismic band was still not completely damaged, and it was in the extent of repairable limit. That means the main objective of the house is to prevent collapse and save life, which was achieved by the application of both seismic band. And we can also see there is a difference between the performance between the timber band and the RC band, which is because of the difference in the size of those two types of band. And with the help with the timber band, there is a possibility of we can enhance the performance of timber band, but for RC band there is no other way we can modify it in order to have better performance. And also with the RC band, we need more time in order to prepare the sample, and we need a formwork of timber in order to make the concrete band. So there is two different scenario for RC and timber band. And with the help of different analysis, we obtain if there is a chance of having only few number of band, we can recommend using lintel band, at least lintel band, or then we can increase the number of band if we want to apply the sea level band. This research work, we have quantified the performance in terms of technical characterizations, but the choice of this type of material also should contain the economic and the social impact, which has to be incorporated in the context of interdisciplinarity. So the perspective of this work is, as mentioned earlier, the behavior and the performance of the timber seismic band can be enhanced, and so more study has to be carried out in order to see the influence of changing the dimension of the timber band. And also another research should be carried out in order to see what is the influence of seismic band in modifying the slenderness ratio for out-of-plane wall. And the approach that was taken in this work could be also used to study the different other materials that is used as a seismic band. For instance, the bamboo or sugarcane materials, or the geomesh that is used in order to separate different level of sections could be used in the similar approach and studied. For the mechanics perspective, we applied 5 level of loading with increasing patterns. But what could be influenced if we apply directly the maximum loading for the structures without gradually increasing the loading should be interesting to see. And also for our case, we had fixed shear normal axial stress for shear wall test, but the influence of varying the normal axial stress could be studied. Another thing which could be interesting to see is to investigate the influence of the drying period of time for different wall configurations. For the socio-technical aspect, the quality control in the field is very difficult, and there is a lot of variations in terms of how it is applied. For instance, the placement of RC reinforcement bar is different, and also the configuration of the timber is different in the field. So it would be interesting to see what is the influence of having different configurations and how it can influence the overall behavior of the structures. And also the next interdisciplinary work which could be interesting to see is to see what is the adaptation on the socio-technical aspect in the community, where our local partners and various stakeholders could play an important role in order to disseminate this information in the site and see how people behave or how they respond in order to adapt this technology. And also another thing is to develop a tool which takes into account the cost and the durability and the other many aspects of social and human science in order to provide tools for a decision maker to select what materials should be used and what could be their performance, whether it is always reliable to use only RC or the timber. It would be a choice with different parameters, not only with technical part. So there is many other things that has to be developed. Talking about the main contribution from this work, 3 scale of experimental campaign was done in order to study the seismic response of the structures, and it was also used for the validation of numerical model for another PhD. And after validating this numerical model, it would be interesting to carry out the parametrical analysis to understand more what would be the response by changing the dimension of the band or by changing the position of this band, which could be also an economic way to understand and study this behavior. Another contribution was we developed a sec table and reaction frame. Even though I was not able to use the developed sec table, we know all the ingredient, how we can redevelop it. So we know what should be checked while making it again to make it functional. Another development was we designed a new method in order to construct the house outside the sec table and move it before the test. So 3 houses was tested for, and the sec table was used only for 6 days. So we could save a lot of time in order to utilize the sec table using the same method. And also another contribution from my work was I introduced an innovative method of applying stackle patterns on the large surface, and which could be used for both the high-speed camera and stereo vision camera system, which would be really good opportunity for different other tests. And for past 3 years, these are the list of journal articles, conference articles, and chapter in the book and research catalog developed. And finally, I would like to thank various people on the site and behind the scene who helped to achieve the goal of all this project in multidisciplinary aspect. Thank you.
Thank you so much. It was a little bit fast, but you speak very fast, so for me that was perfect. Okay, I will say later what I think about your work and your presentation. But before I will introduce the members of this jury in order of appearance for the questions. The first reviewer here is the professor Jean-Claude Morel, who is professor at ENTPE in Vaux-en-Velin, France. The second reviewer is Mr. Gigasu, who is by video conference, but not for the moment. He is from Italy. He is a conservation architect and he is currently project manager at ICROM in Italy. I am the third reviewer of your work, and I will ask my question after the professor Gigasu. And now I will introduce the examiners of this work, starting with Professor Dayala. That's correct? Okay. From the University College in London. The Professor Masquet is from the University of Tribhuvan. I'm not sure about the pronunciation. Yeah. Okay, thank you. He is by video conference from Nepal. And finally, your 3 thesis supervisors will take the floor in their turn. I think that we will start with Philippe, maybe, or Florent. Philippe can start. Donc, Philippe Garnier is a researcher and architect at ENSAG Grenoble. After Florent Vieux-Champagne, who is assistant professor here at the University of Grenoble Alpes, and Yannick Siffert, who is assistant professor at the University of Grenoble Alpes, will close the question session. Okay, now I will give the floor to Professor Morel.
Thank you, Mr. President. I must say that I really like very much your work. I appreciate the challenges you had to face with. And I like very much your work because of different dimensions. First, the pluridisciplinarity. I think you have done very well on that side. And I think the fact that working with the researcher from Qatar is a good asset for you, for your work. And you have managed to work in this field with different skills, with different people. So that's a very good point. And this is very important actually for Earth research, because you cannot see Earth as a industrial material, as concrete, because the background is very different. So you need to have this in mind and to have this multidisciplinary approach. So it is very important to go through this path, but I know that it's also a lot of energy to succeed. So congratulations for that. I think it was very good to go for this approach. I like also very much the experiments, the full-scale experiments. That's really important also for the quite, let's say, a new field of Earth and architecture for research, to have some experimental approach like full-scale experiments or lab scale, of course, for your work. Sorry. I know also experiments are very difficult, and also you had some problem with the fire in the building. So very, I'm very happy that you succeed to overcome all these challenges. And the third point I would like to underline is the analysis of your experiments, because you used a very nice method, I think, very efficient method of, you call it, I think it's DIC, digital imaging. Yeah. Okay. I think this is a very appropriate for this kind of analysis, and you have done well on that side as well. I would like to say also that the manuscript is well written, very easy to understand. That's a good point for you as well. Of course, you know that all work can be improved, so I need to criticize a bit your work. So I'm going to try to make some comments and maybe some critics. So, okay, are you okay with that?
Yeah.
But it doesn't mean that it's not a good word. As I said, it's very good work, but I would like to challenge you on some small parts of the work. So about the water content, or about the sensibility of clay and earthen materials with water. So as I said in my report, I think talking about water is important. You've been writing about it. Yeah. And I understand it's maybe not possible to make a hydrothermal measurement in your case, because you're focusing on the structural level. So I understand that. But can you tell me about that? Do you think, for example, that it is possible to monitor that? For what would you do if you could have more time to deal with this problem? Can you talk about it?
So initially, like before the fire incident, yes, I was working to see what is the drying rate by putting the sample, like cylindrical sample, in the controlled environment to see how long does it take, to have like a stable mass. And also for the mortar, I did a lot of compositions analysis by changing the quantity of waters. But after the fire, like there was limited time, and it was not possible because we had to do some tests in Bordeaux, some tests here, and we had to travel during a lockdown. So it was really complicated. But if I was given another test, I would start by making the compositions to see the influence and to have a controlled environment to see the influence of what would be the influence of temperature and the relative humidity.
Yes, because there's a direct link between the water content, I mean the relative humidity of the air inside the pore, and the compressive strength, for example. So it may influence the results in the mechanical side. So ideally, it would be necessary to have a controlled atmosphere in the lab in terms of temperature and relative humidity. Then you can at least check if there is a similar parameters on that side, because you may have influences. And for example, I was thinking this may also influence the similitude process that you have taken, because you have done a similitude to find the parameters. And if maybe, I'm not sure because I'm not expert in that side, right? And it's in seismic and dynamic and similitude. But maybe it could also be necessary to look for similitude for the water content, the movement in the pore or something like that. I'm not sure.
Yeah, but usually, like if we have, like, because we're trying to compare the result from 3 different structures.
Yes.
And all those 3 structures had same composition of mortar, and they were built side by side. So the relative temperature and humidity in the lab was same for all the 3 structures.
Okay.
So when we try to compare the 3 results, we have the same influence. So it's not like one structure was kept in the one part and another. So it was
maybe you
the
should
same
specify it.
Yeah.
Should
So it mentioned like
okay.
the temperature was 23.
Okay, so I missed it. Maybe.
Yeah.
Okay.
Not at the wall scale, but for
okay.
For the houses.
Yes, the houses. Yes.
Yeah.
Yes.
Yeah.
Okay.
For this one, like there was no control of temperature or humidity. We don't have the roof.
Yeah, I've seen that.
For wall, but all the like wall were prepared the same scenario, so we can have the same result.
Yes, I want about the similitude. Okay, so you have been through the modeling for finding the right parameters. If you don't do similitude, is it a big problem?
Yes.
Why?
Because if we reduce the size of the component, the stiffness of the structure is different, and when we apply stress, will not have the same proportion of the impact in the reduced scale as that of prototype. So in order to have the same influence, the stress level in the reduced scale should be that of prototype.
Yes, but what I would like to say is that I understand, I agree.
Yeah.
But if you focus on modeling, because you're doing experiments for modelization, in a way you don't mind if it is realistic or not. You just want your model to fit with the experiments. So my opinion is it's good to go for the similitude. I'm okay with that. But if you have not a perfect similitude, it doesn't matter because the model should be relative to the experiment.
Yeah.
If you validate your model, that's a good point. It's not exactly what would happen outside, but the purpose of a model is just to forecast what will happen. So you know what I mean?
Yeah.
Okay. Yeah, because sometimes, okay, you can do some very simple things without similitude, and it can be also useful. Okay, so I will switch to maybe a question that is less, well, it's a bit different type of question. It's what is best? Is it concrete band reinforcement or is it timber reinforcement?
So it depends upon like what we want, because what we observed from the house scale test was both the structure was standing still, and the cost of this material in different part of like different region of Nepal is different because of the accessibility of the materials, and we don't have the road network for each district. So even for like the daily requirement goods, people have to travel for 3 to 5 days. So in that case, it depends upon what is available in the site. We observed like both structures performed well for the seismic loading. It did not got collapsed.
Yes.
So it's not only the technical part that we have to look for. So like only looking at the technical result, we cannot make any recommendation.
I agree. That's very good response. I would like to insist about this. Yeah. So, for example, in the background that you know, for example, in Nepal, for example, is it easier to find concrete or reinforced concrete, or is it easier to find timber?
It is easier to find timber, but using the timber, it's very complicated because there are a lot of regulations by the Ministry of Forest
to protect
which
the forest.
have to take permission in order to use the timber available in the forest.
Okay.
So for reinforced concrete, surely we have to import everything from other country. We don't have resource for still member, but for timber, it's possible.
Okay, I have a concern with timber, but I have also concern with reinforced concrete.
Yeah.
So timber, I understand that forest must be protected and so on. Maybe there's a shortage, etc. But my feeling is that timber seems more appropriate in terms of mechanical behavior. That's my feeling. I would like to have your feeling. Because if you see strictly the results you give, maybe reinforced concrete seems to be better in terms of mechanical reinforcement.
Yeah.
But I'm a bit upset about that because I think it's maybe not the best way to solve the problem. So I have questions about that. There's a big difference between the rigidity of both materials.
Yeah.
So that may be a concern. And if I remember well, in Mayotte, I think they had some problems with reinforced concrete with CEBs because of the static behavior. Because then you have cycles with the water, the relative humidity of the air changing a lot. So the earth material is moving differently from the concrete. So you may have some cracks without any seismic long term, with the static behavior. That's I would like to point this out. So maybe it's better in dynamic, but in static long term, there may be some problems because the behavior is so different. Whereas timber is a bit similar because it's a hygroscopic material as well. So do you have any comments on that?
Yeah, I agree with you. And also with the timber, it's like you don't have to mix many things together, and the recyclability of the material is also used when we use timber. So for instance, if there is some damage, we can reuse the same timber. But for concrete, once it's casted, it's permanently fixed. We don't have a chance to reuse it again.
Yes. And another question on the reinforcements. So you talk about the connection between the reinforcement, the bands, and the masonry, the blocks. So do you think it's better to connect it or to have a smooth contact interface between the bands and the walls? What do you think about that?
I think it's better to have like this to allow sliding, so that each part can move separately, and it can help to reduce the out of plane or in plane displacement, and also dissipate energy.
Yeah, so you will remove any connectors, for example. You will not use connectors like we use, for example, for concrete and timber or something like that. Yeah, no, you will not do that. And I was thinking about maybe I was thinking. Tell me what you think about it. I thought that maybe the reinforcement concrete is more efficient to prevent the overturning of the walls, the out of plane, because at the edge it's more rigid.
Yeah.
So the reinforcement is stronger in the edges where there's a weakness and there may be a collapse of the wall, out of plane collapse. Mm-hmm. And timber is not so rigid. So if we had a similar rigidity on the corners of the timber, then maybe we will improve a lot the behavior. What do you think about that?
Yeah, but here, like, we don't have any connections in the vertical direction, so it's only on the horizontal plane.
Yes, but I mean only, yeah. But at the edge of the building, you have two walls then, and one is can overturn. Mm-hmm. But if the bound are rigid, then it prevent the overturning.
Yeah.
You agree with that?
Yeah.
But the timber is not so rigid in the angles because it's difficult to have rigid timber. You know what I mean? Mm-hmm. So that's why I think thinking I thought about that. Yeah. I'm not sure.
But if we have a better arrangement of the longitudinal and the transfer member at the corner,
yes,
we can prevent that one.
Yes.
So we should prevent any many connections at the corner. So it should be like a solid. We should have like an overlap between the band, not which is prone to collapse. So we have to be further away from the the corners in order to have the overlap between the band member.
Yes, yes. So I think there's a real question about what kind of bond do you have and what kind of interaction you have with maybe the corners should be different from the middle. I don't know.
Yeah.
Okay. Can I still?
Oh, yes, of course.
Okay, I'm nearly finished. Yes, I talk also about elasticity of the material. So it's a bit a challenge about elasticity with this material because there's not much information on that matter. I'm a bit convinced that it's not elastic, and it's always a bit elastic and near zero.
Yeah, but after that, then there is
yes, there's a kind of I understand that it's a bit difficult to assess it. I was wondering if you zoom one of your figure, for example, the figure 4.7, it's hysteresis and envelope curves of Adobe. It's a wall, is a structure, right?
Yeah.
It's not the material, basically you have the joints, but near zero, I think maybe it is elastic, but if you zoom this kind of curve, maybe you can assess if it is elastic or not, but I'm not sure, I'm just asking. What do you think? Yes, this kind of curve. If it is elastic, it's only a line, isn't it?
Yeah. But in our case, like we have a little bit of loop. So
yes, so you can see it's not elastic. Yeah, okay. So that's just I wanted to point this out. Yeah. So, okay. And about last question, it's about the digital imaging. I think you've been, as I said, it's very hard work because I've done that when I was younger. So I can understand why it was not digital at that time. It was analogical, but
and for each house, like we had 19,000 images. One piece.
Yeah, so it's different. Yeah,
so 19,000 times 5 for each house configuration.
So you do much more now.
Yeah.
At that time, I had only 2 slides. Okay. So 2 by 2, you know. Yeah. So you use different analysis because with the walls and the structure. In the structure, you use the shear strain, if I remember well. But in the wall, you use the principal. Why?
Because in case of structures, there might be some torsional effect, which is not captured if we only look at the shear. That's why to have the major strain value, we use the principal strain.
Yeah. Okay. And you have been trying different values, but you didn't present it there in the manuscript, I guess. For example, did you see the displacements on the walls and you analyzed that with the DIC, the displacements, for example? You didn't provide it, but you have done it, I guess. Yes, you have to see it. And okay. Because I think that also, I'm not sure if I remember well, but did you have some points on the bands? Yes. You had some points on the bands, so you could see the difference. Yes, that's what you were saying. Yeah, okay.
And also the sliding at the interface was used by taking the result from the digital image correlation.
Yes. So I think you really you really use well the digital imaging. Yes. And this is very powerful tool. Then you can have all the tensor, the strain tensor. So that's for modeling, I guess. Maybe so it's interesting because you can compare the tensors. That's so congratulations again, and thank you very much for this work. And this is very important. This work is very important because you have this approach, multidisciplinary approach, so you know where you go. For example, you are not going to stabilize the soil because you know so that it's maybe not relevant in the context where you are. Okay, so
and also for the environment, like if you stabilize, we are trying to add some.
Yes, of course, and you're not going to resolve the problems with the global warming and so on. So that's very good, and thank you very much. Mr. President.
Thank you, Jean-Claude. I'm not sure that Mr. Shigasu is online. Can you please ask him, Santosh?
Yeah.
Because he doesn't hear us, isn't it?
No, he can hear me. I think he can hear. Dr. Roy? He said like he will be away for a few minutes.
Yeah.
He had something.
Okay,
Maybe we
I can begin.
Yeah,
Okay.
you can begin on that.
Okay, no, I will take the floor as a reviewer of your work. But before I start, I would like to thank you three supervisors for inviting me to your defense and for offering me the opportunity to report on your work. I found your work extremely interesting, and it was a great pleasure for me to read your manuscript. As my colleague, Professor Morel said before, I found your manuscript to be very well written. I liked your style, the style you used, synthetic, direct, and efficient style, and it was the same during the oral presentation. It was very synthetic and clear, and even though the thesis is written in English, it was not difficult for me to read it and to understand. So I want to congratulate you for that. I also want to congratulate you for your presentation. It was very impressive. That was a beautiful presentation, very, very clear, very, I'm not sure about the word in English, pedagogical, please help me. Yes, yes, thank you. And I want to congratulate you again for that. Before I start my question, I would like to underline the overall quality of your work as I did in my report. I have very appreciated your work for several reasons. That was a little bit the same than Professor Morel. First of all, the multi-scale approach you used is very relevant for these studies, but it is often difficult to carry out, and therefore it is relatively rare. And your work is very a good contribution for the scientific community because of this multi-scale approach. The culmination of this work is a building scale test using the dynamic shake table. That is very rare, that is very difficult, that costs a lot of money, and you have used this shake table during your PhD, and that's very good things for your work and for the understanding of the problems of this type of structures with the seismic problems. The second thing that I really appreciate about your work is that it concerns a very concrete real-life problem, and it will therefore have a very rapid outlet. These results will be directly usable in Nepal, but elsewhere in the world, and for the training of engineers, architects, masons, and for the public decision makers too. I think that is a very significant contribution. You haven't go so far as to give concrete advices, for example, on the number of seismic bands to use. I found it was very courageous, and that is very useful for architects and engineers in Nepal, but also everywhere else in the world where there is a lot of seismic activity. Your work is a great contribution for the people who live in these countries. Now I'm going to ask you some questions, but don't worry, not too many, because we are many people in the jury. And in contrary to my colleagues, I have no critique on your work, but some question. And as I'm specialist of construction material, I will ask more question about the materials. And I had a problem when I read your manuscript with the experimental choices you have done. Sometimes what's not clear and it was not. That sounds strange, and I don't understand why. I didn't understand why. And today I have understood yes, because I didn't remember your problem with the fire, and that has completely changed your initial choice, and you have to you need to adapt, and I have understood a lot of things today. But I have a question. Just one detail in your introduction on page 11. You have shown the same pictures. You talk about earth construction, and the two pictures you show.
It's with a stone.
Yes, that's a pity.
Yeah.
I think that today we can see Nepalese house built with earth.
So this one is with Adobe.
Yes.
Yeah.
From Nepal?
Yes.
Ah, great.
Yeah.
Thank you.
The problem was because when AECC was working in Nepal, they were mainly focused in 3 districts, and in that 3 districts, it's more like the stone is more available. So we had picture of stone masonry, but this is from another Kabre Palanchok district of Nepal, where they have used Adobe with a different kind of plan.
Okay, thank you. Okay, my other question will be on the experimental choices you have done, but I'm not sure that we could speak about choices. Maybe you have no choice to do that. Okay, because you have decided to work. That is right, written like this in your manuscript, that you have worked with 2 types of bricks, adobes and extruded bricks. Many questions about the adobes. It was not clear for me how they were manufactured. You have bought them, or you have manufactured them?
We bought it from LS Cap, like it is close to Grenoble.
Okay, and why did they add straw in the adobe? You know why or not?
I don't know. Usually, like it depends upon the manufacturing company how like they want to quantify their material. So for Adobe, they had hemp and sand along with the clay.
Hemp or straw?
Hemp straw. Hemp.
Both?
No, hemp.
Hemp. Yeah. Okay. They use hemp inside the Adobe.
Yeah.
And do you know why?
I don't know.
Is it conventional to add straw or hemp or fibers in Adobes?
It's common, yes.
Yes.
Yeah. Even for mortar, like we have like different composition. We add straw, or also sometimes we add cow dung in order to increase the strength.
To increase the strength?
Yeah.
Okay. Okay. So that sounds a little bit strange for me, because that is not so common, but that could be.
Yeah. In my country, like we mix the straw with cow dung in order to make a plaster, or in order to lay the.
Yes, for the plaster or for the mortars, that could be explained by the fact of the sorry for my English. Well, for the shrinkage and the cracking. But for the Adobe, if you use sand, that is not necessary to use aggregate fibers. But okay, you have not chosen that. No. You have bought the Adobe. Okay. And my second question, maybe I think that I have understood. You planned in the beginning of your work to work only with Adobe.
Adobe, yeah.
Okay. And because of the fire, and because you have you need to have a lot of bricks, and you have bought extruded bricks because of the number of the bricks.
Not only the number, also like we're trying to do it in the reduced scale. So the size of the brick has to be reduced in the same manner. So we have reduced scale for brick, also for mortar joint. And also the fact was we wanted to do it in Bordeaux, which is like more than 700 kilometers far from here. And it was not possible to have manufactured at the same part. We also tried to contact them, and they said like for different size of Adobe, we are not capable of producing. Okay. And also the fact there was a lockdown, so a lot of things were changing every time, and it was not possible to get Adobe brick for our required size. Okay, so you had not the choice, but I have a little bit I have a small problem with the extruded bricks, because in your work you are shown during the results of shear resistance that there is a very low bound between this brick and the mortar. Yeah. And I think, but maybe there are other specialists of earth construction around the table, they could give their opinion too, but I think that the bond between the mortar and the brick is the basis of the resistance of the wall. And I ask myself if these extruded bricks, as they are for the moment, can be used to build a wall. What is your opinion on that? I think like it has got very smooth surface, and it creates very low value of shear resistance. So with this behavior, it's not usually recommended to use extruded, unless like we modify the quality of mortar, which could enhance the shear resistance of the interface. Yes, and have you thought to modify the surface of the bricks? It was too difficult. No, like we did not try anything, because we had only 2 weeks in order to prepare 3 houses. Yes. So it was no choice. Like we had to do it everything very rapidly. Yes. Okay. If you have to build your own house in Nepal, do you want to use the Adobes or the extruded bricks? I would go with Adobe. Okay, I agree. But that is not because the bricks are extruded. I'm not against the extruded bricks. I work a lot on with the extruded bricks, but these bricks, there is a problem with the surface. Yeah, that's clear. Okay, another question. I'm not sure about that. Maybe I'm wrong, but I think that I didn't find in the manuscript the dimension of the timber seismic bands and the height. It's in the annex. Ah, okay. So okay. All the dimensions. Okay, that's my fault. Sorry. What is the height? For house or for the wall? For the, that is not the same for the wall and for the for extruded bricks we use the same band as that of house. Yes. But for the Adobe brick we have different size of band. Yes. And what is the common size for timber seismic band? So it's a 45 millimeter height, and then there is 75 millimeter of wood. Okay. And there is a like longitudinal member is 75 by 45. And the transfer member is 50 by 45. Okay, and is this does this eye play a role in the behavior of the wall? If it is higher or if it is, does it play any role or not at all? Like the placement of the band or like the size, you mean? The size. For now, like we don't know, but I think it could influence, but we have to explore. Because the sliding, that's the word. The sliding will be the same, even if the band is very large or not. Yeah, but I think it could influence the overall rigidity of the structures, because if we have a smaller size, the rigidity will be lower, and if they are bigger. You don't know the smaller size that could be used efficiently? For now, I think no. You have no idea about that? No. That's why like we have to do like a parametric analysis from the numerical model in order to see if we change the dimension, what will be the influence. Okay,
I have a last question that is a little detail in your manuscript. That is, I want to ask you this question on page 93, 94.
Yeah.
You talked about the slipping of mud.
Yeah.
You remember?
Yeah.
By explaining that letting mortars rest for several hours activates the clay particles. Could you please better explain me what is this activation? What is activation is?
So when we put water in the clay, it starts increasing the volume, and which enhance the cohesive nature of the clay material. So it is generally practiced to have clay sit in the water for several hours before we apply, in order to prevent the extra the increase in the volume of the mud mortar and then the shrinkage.
And this increase of volume is the same for all the clay minerals, or
no?
No.
No.
Do you know the nature of the clay minerals in your mortars or in your bricks?
No, we have not quantified like that, characterized.
And do you think that you have expensive clay minerals or not?
I don't know.
You don't know?
No. But we tried to check if we had enough clay content in our soil or not. For that, we created a sample of balls, small balls. We let it dry for, I think, 24 or 48 hours before we try to, then after 48 hours, we try to break it, that small ball. And if we can easily break, that means the clay content is lower. Or if we cannot break, that means it has got adequate amount of clay.
Yes, that works for the clay content, but not for the nature of the clay.
Yeah.
But if you add clay, expensive clay, or clay, very active clay, you will have a lot of problem of shrinkage and cracking. But okay, that's what's not possible to study everything during your PhD, and you have not focused on this characteristics.
We did like compositions of mortar. We characterized the composition by changing in the same clay. We added sand, different percentage of sand, and fiber, in order to see like in which composition we have less number of cracks.
Yes, we do the same into this.
Yeah.
Okay. Okay, thank you very much. Oh, Mr. Gigasu is here, so I can give the floor to Mr. Gigasu, please.
Thank you very much. Thank you. And first of all, really pleased to be in this defense of Santosh. I'm very, very pleased to kind of look at his work, which is everybody has mentioned things which I would not repeat. I think what I really feel the most important, I would say the value that your research carries is the fact that you have looked at it at different scales, that you have looked at it different levels. And I think that kind of holistic view is really important. And I think for the first time, I could see something like that being attempted. So congratulations for that. I also like the way you have put it all together, because you can easily get lost, especially me being not an engineer, but an architect with specialization in heritage. I would be kind of intimidated, and to be very frank with you, I was, when I looked at your work. But when I went through it, instead, in spite of all the calculations and the details that you have done, it was very easy for me to really understand. So I really value the fact that you have put it all together in a very systematic, clear way, and you illustrated it very well. So I think the fact that your research work has been written so well in a well-structured, illustrated manner is the other important value that I must appreciate for what you have achieved. So again, congratulations for achieving that. The third important thing, which I feel is something that is of high value from your research, is the fact that you have based it on something very, very practical and very much in need in Nepal and in other parts of the world, but also I would say in the South Asian region, because a lot of these typologies that you have looked at are not only in Nepal but also in other countries, whether we talk about Bhutan or India or other countries. And so I think it has a wider applicability, which comes from something which is a need from the ground, and you have kind of very boldly addressed that issue. So I think that's something which is going to be very helpful beyond the scientific community. And my next questions actually come from that, because any research, especially the kind of research you have done, Santosh, is really should go back to serve the community and the society at large. There is a little gap that one has to cross, which is always a gap. I mean, it is research needs a little bit of scaling down to translate into something that can be put in practice, no, in terms of the kind of challenges that one faces, whether, as earlier jury members also mentioned, whether it is with regards to the materials available, or whether it is regards to the economic viability of things, or whether it is with regards to the kind of houses people build. Because even if you advocate a certain typology of houses, people will build not only because they are structurally safe, they will also build because they would like to have a design which is very much according to the way they live, no, according to their socio-cultural practices, which means that the housing in from the architectural typological view will have many different design forms. So that is my first kind of question to you, in fact, which is that how do you think you have of course experimented and looked at a one particular model which you think is, by all the reasoning that you have given, and rightly so, in terms of the symmetrical form and all the kind of detailing, is not going to be the only design that will be followed in real world, right? So how do you think your research can have implication beyond the typology that you have looked at? What kind of permutations and combinations you think can be advocated? Because somewhere down the line I was missing that part, which can be very helpful, that you have an ideal design, but then you also work with different options that you look at from the point of view of giving people a little bit of flexibility on applying the lessons from your scientific work in the field.
Yeah. So it's fact, like in Nepal, we have different kind of typology, and like people build their structures in order to fulfill their needs. So some people have like a antique where they store their food crops, and they have like a same house that is here also for the animals and for the people. So like if we move from one place to another, like we have different type of typology. And also in case of city area where there is a lot of urbanization, we have row houses rather than having a single standing house, freestanding house. But in case of rural part, we have standing house. So people build like 2-room or 4-room house for their like small family. And this approach would be useful for single house, but for row house, we have to study what would be the influence. And also recently, like after the earthquake, they had new regulations passed by the municipality in order to have some space in between two houses when they have to build it. So now it's not allowed to have a row house in most of the municipality in Nepal. So, but for row house, there is an influence regarding the stiffness of the structures. And during the earthquake event, there is a like two different like natural frequency of the structures. And I have experienced myself the pounding effect between the two structures, which was side by side. And usually structures also share some of the structural component. So for instance, one has wall, other house doesn't build their house wall. They just have their frame. So there is a lot of things, but I think for earth masonry structures, for the new construction, it's always having a freestanding. So we can look at that one, but to see the influence of having two structures in the row format, we have to carry out the numerical simulation because it's not possible to build
Of
that.
course, of course. No, absolutely, it is not possible, and I definitely understand the fact that all that kind of experiments you have done, even to construct a model of is a huge undertaking, and also with the unfortunate incident of fire that you explained, and I think it's incredible what you have achieved. What I would just say is that if there is a little bit of reflection of this, because at the end your research also somewhere at the end people will look for what the implications are on the ground, and I think if that kind of reflection comes out, it will be very useful for people. They will not look at it as only some scientific work, but will see that there is a lot of impact that it has on practice. So well, the other point I wanted to also make, and I have put it in my report also, I think it's incredible that you have really worked in what you call as a what you say it in this yes, you say it's a multidisciplinary work, and you have worked across different disciplines. And also in your presentation today, you also showed that you have looked at different engineering aspects, and you have looked at the architectural aspect, which is really great. But I also feel that somehow I feel like one has to also include other disciplines which probably are not building related disciplines but have a lot of impact, whether they are anthropology or sociology. I know that they seem a little bit very far away from an engineering, but since you set out for yourself a challenge right from the beginning, that you are going to look at it from this multi-disciplinary perspective, it would have added a little bit more value if you had looked at a bit from the point of view of it's not about how people live in a house, but it's also in terms of how people perceive. Because what you also can, I'm sure, appreciate from your own experiences, that sometimes people perceive things in a certain way. They believe that this is strong and this is not strong, and they think this is cheaper and this is not cheaper. They think this is easily. So it's also important at certain point to also look at people's perceptions, people's beliefs, and also take them into account. Why people choose a certain material, why people choose a certain way of building. And I think if you can incorporate that, or at least reflect on that, it will also help. For example, organizations like my own, when we go out and start to do capacity building or training activities, we know what is the aspect that we need to change, whether from the point of view of the house owners, whether from the point of view of professionals. So I think it is important that not only building related disciplines, but we go a little bit beyond other disciplines. And here I would also like to add, and maybe you already considered that, and that's very much connected to engineering, and that's more geotechnical issue, which is really about it's also related to foundations and the ground on which houses are built. So I mean, have you considered that? So I mean, all these I just wanted to put together to you and have your reflection on this. Thank you.
So for my case, like I have not considered like there is influence of ground motions depending upon the topography. But in our case, I have considered only like one earthquake signal that is tested for 3 structures. But for sure, there is a lot of influence regarding the composition of the ground, the geological condition of the soil, how thick is the soil bed, or where is the rock, and what is the locations of the epicenter of the earthquake. And also, like yesterday, I was in the conference of organized by NRA, and there was an interesting thing regarding why we don't study like earth constructions in our curriculum. For engineering school, we study concrete, steel structures, which is good for taller building. But for traditional construction, we lack to transfer the knowledge of earth constructions. We never study about what is the behavior of earth construction. So also like regarding the governance strategy, when we look at, there was a comparison made in 2016. Maybe I have a slide in order to show you.
Yeah.
It's interesting to see. Yeah, so here, so it was made in 2016, where they compare like two different, like one is for Nepal on the left, and on the right it is one of the state in Bihar. So here what we see is the research from the university and the teaching is at the bottom of the pyramid, and the things which are on the top, on the peak, has more influence in governing strategy for Nepal. And as we compare for Bihar, we have university that is a bit higher from the bottom. So we have to focus on incorporating this research work and move it towards the peak rather than having at the bottom of the pyramid, which is more important in order to disseminate this information to the community.
Santosh, I mean, I think this is what you're saying is really, really important. And I would say that my work in Japan over last 15 years, one of the important learnings working there was that university is rather at the higher level, even higher level. You know, it is at the maybe at the top of the pyramid. Sometimes Council of Ministers listen to what a university professor has to say, you know, directly. So I think this is definitely one of the important things that we have to work with, like how can we make universities and the findings in the universities kind of go up the ladder. So I think that's a very important point you're making. Would you like to reflect on the social and the other disciplines? Have you considered at any time that would have kind of added some value to what you were doing? Of course, you would have done your research in a certain way, but do you think like inputs beyond just the building disciplines would kind of add a value, or maybe not your research, maybe in the future if somebody else wants to work further on what you have done, you think there can be an added value of including other disciplines?
For sure, yes, because like the whole project has got a lot of like stakeholders involved, and it's not only like engineers who can address many things. There are sociologists who knows all the information from the site. There are environmentalists who knows the information from the site. So it's like collaborative work from different discipline who needs to work together in order to find what is the problem, how people react to a certain kind of recommendation, and how they implement it. So for sure, there should be more work in this regard, where a lot of discipline of people can work together to resolve the problem.
Right. So I have just last point I wanted to make on the work that you have done, and that is actually more on the fact that what do you think should be the next step after your research? If any other researcher has to work on what you have achieved in your time, and let that person be the coming from your main discipline, what do you think would be the recommendation for that researcher to do as the first thing based on what you have done, which you have not accomplished because you have just you have a limited time and a limited, what would you recommend?
So for the new researcher, I would recommend using the numerical model that has been validated in order to carry out the parametrical analysis. That would be the first step in order to see what could be the another step in order to see the influence of the material or the positioning of the band in order to perform another experimental setup. So the first step would be definitely to have a researcher who could work on the parametrical analysis.
Great. Thank you very much. I think I would just like to conclude by saying that I think your research has one very important added value, and that is that it shows that any traditional knowledge has to evolve, and you have to actually look at it from contemporary perspective and try and see what we can learn from the past and how we can adapt it for today's context and for the future. Of course, we can always romanticize about traditional knowledge and say that, all these wooden bags are great, and all the traditional buildings are great but to look at what is the best way of building them, and whether there are alternatives if wood is not available. I mean, there was a discussion earlier as well. So I think it's always about learning on how to evolve over time, and I think you show it with your research. And I think that's a very important takeaway, I will say, for also for the heritage fraternity, who is looking for, at certain point, we try to re-emphasize the importance of vernacular housing. But vernacular housing will not remain vernacular if we just continue to build in the way people used to build many years ago without updating them to current scenarios. So I think you have shown away from your own research, but of course, there's a lot more that can be added. So congratulations to you for this excellent work. I have really enjoyed it a lot. I just hope that you will take it to that next step, at least to write a little more on the implications of your research in practice, because I think there are a lot of implications. Thank you so much.
Thank you, Mr. Jigasu. Now we will give the floor to Madame Daila.
Thank you very much. First of all, I would like to congratulate you on the quality of your work. I was very impressed by the extent of your experimental work, especially after I heard of what happened and the fact that you still managed within the 3 years to produce so much. So congratulations to you, and also to your supervisors and your team that have supported you so well. I would like really to pick up where Rohit has just finished, because there is a very important content here, which is the connection between let's say ordinary building and ordinary constructions form and engineering. And very often we think about engineering only in terms of steel and concrete, and we don't appreciate the level of engineering that there is in ordinary constructions. And we call it vernacular, we call it historic, but in fact, there is the same level of ingenuity in realizing certain solutions that there is in what we today consider engineering. And it is true that that might not have occurred through the applications of maths and physics law on a piece of paper, but in fact, it has evolved with the same understanding of what the force of nature can occur upon structure. So I think it's very important, and you have made quite an effort here to apply procedures that are very technical, very, let's say, common to engineering approach for engineered materials, to a situation with, to materials and to ways of construction that are traditionally not engineered. So also congratulations on that, because also you have obtained a very robust set of results. You have looked into their statistical distributions. You have looked into the meaning that has in terms of how you can extract values that are operational, let's say. So I think that's also a very good result in that respect. As I am a structural engineer, I'm going to ask a few questions that are more specific, and I've worked on masonry for the past 30 years, so that's my focus. And so I will just go a little bit through the dissertation, if you don't mind. Well, the first thing that you have done is the characterization of the materials, both at the level of the adobe and at the level of the mortar. So my first question was why, in your analysis, there were, or at least in the write-up, I don't know if you have it elsewhere, there was no reference to granulometric curves for the choice of the Adobe that you have put together and for the choice of the mortar.
We didn't carry out the granulometric.
Yes, and was there a reason why you didn't?
There was no major reason, but we wanted to have the same mortar for 3 structures. So we wanted to compare the behavior of seismic band rather than having the influence of like the granulometry of the mortar, like the mortar itself.
Yes, the fact is the granulometry gives us very specific characterization of not just of the mortar, but also of the Adobe mixture, which can then be reused by future researchers, which in this case is a little bit missed, let's say. So, and I would like to understand whether you have an explanation, for instance. So why do you think that your mortar had substantially better characteristics than your Adobe, especially in compression?
Because for the extruded brick, there is like we have there is a pressurized compactions of like, so there is a reverse pressure maintained for the extruded brick, and which creates extra compactions of all those materials.
Yeah.
So the density is higher.
Yep.
And also the composition for our case, it was different.
Yeah. No, I was asking the correlation, the comparison between the Adobe's compression strength and the mortar that you use in the Adobe compression strength. Yeah. It seems that the Adobe strength is substantially lower.
Yeah. It's because of the composition and the way it was manufactured.
Okay. So, so you didn't investigate that a little bit more, because typically one tries to have units that are of higher strength than the mortar, so that the cracks go through the mortar instead of going through the unit, which in fact seems to have been one of your problem. And you didn't think of using any type of stabilizers in the. And why was that choice?
Because the choice was in the field, we don't have any stabilizer used.
Okay.
Another is in context of preventing the environmental impact. It's suitable not to have additional stabilizer used for one more time.
Okay, thank you very much. So my next question has to do with the, because you have been already there defending for a long time, so I will be quite quick. I think if you go to one of your slides, I think it was the final one. You compare the results from the one from the walls and the one from the. No, this is across the walls, but you have a conclusive one where you were comparing the walls and the houses. Yes, this one. So it seems here that there is, when we look at the effect of the timber bands on the individual wall, it's much less effective than when we look at it at the level of the dynamic test results. Do you have an explanation for that?
So for that one, we are looking at the energy dissipation. And for quasi-static, we load it until we reach the failure. So it's not the same scenario for both. So here we are looking at the maximum load capacity, maximum ductility, and maximum energy dissipation in the quasi-static. But for dynamic, we have the same level of loading for all the 3 structures. And here we are comparing the energy dissipation.
But why do you think that there is such a good contribution? If we look at the condition without the band, there is clearly a substantial improvement when you put the timber, and that improvement is very comparable with the improvement in reinforced concrete. But this is not the case when we look at the seismic band in the one-dimensional element or in the two-dimensional element.
So the performance of timber is lower because when we apply timber band, there is the mortar and the timber joint is not very strong. When there is shrinkage, initially the timber absorbs water, it swells, and during the drying there is small gap in between. So it creates a weak joint between the timber and the mortar, which creates the lower value for the timber.
And why that is not repeated in the 3D condition?
No, but if we look at these two values, so we have to compare this performance with respect to this one. So here we have close enough, and here is also like 34%
Yes.
and 46%.
Exactly. Yes.
Yeah. But it's not what we are looking at with the peak load and the ductility.
But usually people design in terms of peak load and ductility. So what does that tell you in the more general scheme of things?
So in general, for the peak load, we have lower capacity with application of timbers, but the ductility is increased. We don't have a lot of difference, so it's like 8% and 13%. So it's close in both cases.
Okay, thank you. So I just now want to, I think this is an element that we have not maybe explored much in this conversation. How do you move? And I think Roy slightly pointed you in that direction. What are the implications for design or for recommendations for implementation in the field? So
for now, we have to share this result among various stakeholders because there are a lot of scientists, a lot of engineering associations, and there is another government body, DUDBC and Nepal Reconstruction Authority. So we have to share this information to them because it's a new result and they don't have access to this kind of thing. So first thing would be to incorporate other stakeholders and our local partner in Nepal in order to see how we can share this scientific information with the authority in order to implement. Because initially during the reconstruction, they had they always try to have influence regarding we should only use reinforced concrete in order to obtain the financial grant from the government. And when there was change in the authority, like people used to change themselves, so that we have difference in like for one band they have timber, for other they have reinforced concrete. So it should be shared among various stakeholders in Nepal.
So for instance, if you were to recommend the number of bands that should be, or the essential bands that should be included in a design, which you would recommend? Because clearly the bands are costly with respect to the bricks. And for
So for single story house, we didn't find any advantage of having roof band, so we can get rid of roof band. But the most important one was the lintel band. So, and after that, the second important was the sill level band, because at the openings there is a stress concentration which can lead to crack generation and the propagation. So if we can restrict that two part, which is above and beyond the opening, it would be the recommendations for the first phase.
Which is very interesting because in fact, in most recommendations, the only band that are recommended are the roof band and the cleans band, but not the seal and
yeah, but in our case, like
not the seal and the lintel. So this is a quite and there is a good reason why they are like this, because they refer more to the confined masonry, or they come more from the confined masonry tradition. But the confined masonry tradition has the vertical column that connect, that close the panel, which here you don't have. Which takes us to two different things. One is you mentioned earlier that you think that it's best to not connect the band vertically to the brickwork. I call it brickwork, but I mean the block work, let's say, which is a bit surprising because traditionally, I think the way, especially in Nepalese construction, the bands are always connected into the masonry work with pegs in different positions. So why have you arrived at this decision?
Because usually, like if we have a reinforced part that is running from the bottom to the top, the stiffness of the reinforcement part and the adobe is different. So in case of shear loading during a seismic event, it can create a stress concentration. So one of the study that was done in 2005, he had tried to have like interior member with a different material with the bamboo, and he observed that with that configuration, he had lower resistance and it fell earlier than the other one. So also another thing is we don't find this kind of vertical member in a lot of house. It is very complicated to use inside the wall. Usually people have at the corner they put a vertical post, but again with that vertical post it creates two types of structures. One is with the timber and another is the load bearing structures. So,
yeah, the vertical. I think the vertical reinforcement at the corner in the masonry in the block is actually recommended by the National Building Code of Nepal. What I was talking about is more relating to the timber band. Traditionally, timber bands in Nepal are connected via timber pegs into the brickwork, into the blockwork. So are you suggesting that this is not a good solution, or do you think that is a good solution?
For me, like I'm not aware about like how they peg the timber band on the wall.
Well, typically they are rather in between the two blocks, or in between the blocks along the transversal ones, or sometimes they are just external to the block so that there is no transversal sliding. And when you close the frame in 3D, then that also is very useful to prevent the out of plane behavior of the walls. But maybe it's a detail. I think it's yes, it's common.
And because from the reconstruction report, like what we observed, people were not seen using such kind of anchoring. That's why, like, we choose what was practiced in the mostly affected district, and we just took what was practiced in the community to study what would be the influence.
And finally, my question is, again, it's towards a practical, let's say, implementation. Of course, you have used a large number of different measures to determine the performance of the structure, well, both sides of specimen towards different within your test. How would you use these in order to? There is clearly scope for using some of those measurements in future research, and you have mentioned further numerical analysis, parametric analysis, and so on. But what are you learning from those measurements that can be translated into, again, practice and design recommendations?
So I think from the quasi-static test, we can have the characteristic curve, the bilinear curve, which will be used for design purpose, which determines the capacity and the yield limit and the ductility limit of the structures. So that could be used for the design purpose.
Do you think, because this is, I think, a very contentious point, do you think that 2D analysis and curves that are being extracted from simple 2D or simple wall tests in plane, therefore only considering the shear capacity, are actually can actually represent well the behavior of the 3D structures and should be used to determine the capacity of them.
Not exactly, because there is always influence of out of plane and in plane behavior in the structures when we talk about the 3D. But this gives a little bit indication regarding how it behaves in context of in-plane work. But definitely we have to do more work in order to see what is the influence in the out-of-plane structures, which has to be done.
Thank you very much. The only things that I would say in respect to the written dissertation is that I would have liked in some parts to for you to go a little bit deeper into the why of certain decisions, or a little bit deeper into the explaining the consequences of some of the results that you had. But otherwise, it's an excellent piece of work. Congratulations again.
Thank you, Professor. I will give the floor to Professor Masquet.
Yes, thank you. Thank you, Santosh. Now, first of all, I would like to congratulate you for the nice work and also the nice presentation. That is the first point. Now, I do have a couple of comments and couple of suggestions and couple of questions. Now, many of my colleagues have already asked the question, so I'm not going to repeat all those things. But somehow, what we have to understand actually is, unless and until, we go for practical application, so there is no need of research and academia actually. So be careful about that, and we should not forget about that. So unless and until we reach to the community, we reach to the practical part. So there is no question of using our research or academia. So be careful about that. Now, this is not comment, this is not criticism, but we should remember that. So that by saying that, what I mean to say that you have to look at the other side of the research also, what we are going to get it and how the community is going to benefit from that. And my colleagues also have explained a little bit, like Rohit and as well as Professor Dera Diala also mentioned about that. So be careful about that. Now, the second point, very important, is we should also be careful, not only in scientific this research, test, etc. So we should be knowing about the use of materials, etc. in the community. So they must be accessible, they must be acceptable, and they must be affordable. So these are simple words, but these are very important things. All right. So call it timber, call it bamboo, call it reinforced concrete, whatever it is. So we should also think about the use of these materials, possibility of use of these materials in the society. Particularly, let us say, if you are from Nepal, so then don't forget about Nepal. That's my request. All right. So now in that regard, you have rightly done the thesis. Actually, the topic also is very important, and you have tried to endeavor to quantify the performance of two most commonly adopted seismic band materials like timber and reinforced concrete, which is very good. And so you have distributed the whole thesis into 6 chapters, starting from your introduction to, let's say, state of art and materials, wall and your house, and also results and discussion, etc. It is fine, it is good, but we should actually eliminate all the gaps wherever it is there in the chapters or at the conclusion, whatever it is. So the first and very most what I would like to mention actually is, what you have to do actually is, first of all, you just note it down that there are so many results, there are so many experiments you have done which are very expensive, I know, but you have not, maybe due to time or something like that, you have not been able to give the discussions of the results, so through which we have to conclude what is the conclusion. All right. So unless and until we discuss what are the problems and what are the results, sorry about that, we won't be able to conclude. So that's why please try to give some discussions of the results of timber bands, results of reinforced concrete, or results of adobe wall, whatever it is. Discussions are required. That is for foremost and the first thing what you require. Now the second thing is, it's not that my interest, but it would be very beneficial to Nepalese society and community if we could just mention about, you know, the requirement of these timber, for example, because you are basically emphasizing on timber bands. What type of timber we are talking about? Sal, or let us say your siso, or maybe, you know, these other types of timber. Whatever timber you have not mentioned about that, and whatever is the hardwood or softwood doesn't work. You know, I mean, you have to mention what type of timber we are talking about. Then only it could be used. So basically, sal is the hardest, the most hard timber used in Nepal, but not necessarily it is available everywhere, and it is not very, you know, cheap, and this is the most expensive. In that regard, also we have to think something else, because as I told you, unless and until it is practically solvable, there is no need of doing any research. Be careful about that. Now the third thing I was interested in about mud mortar. You know, you have not mentioned about mud mortar, but you have mentioned about the adobe, you know, all these things. But looking at all those experiments and all those your, you know, these things material wise, so we should also mention about, you know, this mud mortar, because mud mortar cannot be avoided, particularly in the rural houses, etc. And you are mentioning about the experiments of houses which are 2 stories or 1 story, single story, like that. All right, for that purpose also we should be careful about mud mortar. Mud mortar is not unusable actually. It is prevalent in Nepal rural houses, etc. And this is very good, provided that you go for the right choice of the materials. All right, like for example, people are using without even testing and without looking at the components of these mud mortars. So what it should be, we should not forget actually, is the clay content should not be more than 20% anyway. So that is the most thing about silt, sand, whatever it may be, but it should not be more than 20% of clay, because increment of this clay would result into, you know, shrinkage and the loss of strength, etc. So you please mention about that, and what is the use and what is the, let us say, perspective of this mud mortar also we have to mention, because practically if we are talking about, this is the one which will people like to seek about that. The fourth point, next my comment actually is, you know, I mean, different types of these bands, timber, RCC, you have mentioned right well, but I'm talking about the seismic bands. What are the locations and what are the spacing? You know, I'm not asking you to develop some code provisions, etc. But somehow, at least you should mention. Like I have seen in your sketches also that you have series of horizontal bands, etc. But spacing, etc. are not mentioned there. And apart from that, most important is vertical bands. Although I know that your topic says that horizontal bands only, but if we are talking about adobe, or if we are talking about, let us say, masonry, all right, then we should not avoid the vertical bands. No, doesn't matter whether it is timber band or concrete band, but it helps quite a lot. So please mention at least in some places what is the role of vertical bands, maybe timber, doesn't matter. Okay, and what are the limitations of timber bands, also you have to mention that. So this would be my fifth point. And then, you know, I mean, then this limitation of, you know, I mean, this I'm talking about the research, you know, continuity of the research, what would be the continuity research in future. So that would be my sixth comment, sixth mention. By that, what I mean is, you know, wherever we do some research like PhD or these things, always continuity should be there. My other colleagues also mentioned about that. All right, what would be the recommendations, what would be the next step, etc. So if we do that, that will be even better. Okay, so you just mentioned what are the possible recommended topics for the future regarding these things. All right. So now think about that and just mention in your thesis about that also. So more than that, I don't want to say because almost everything has been mentioned by my previous colleagues, and so think about that and write it down. So having said that, thank you very much.
Thank you, sir.
Santosh.
Thank you for.
If you have to say something, please, you are welcome.
No, like you have really raised several issues that has to be addressed, and it's not only like the research we do. We have to also focus for the real implementation in the site, and how we can continue to understand what is practiced in the field and how we can help the community to build back better.
Right.
Thank you, Mr. Professor Maskey. Now we give the floor to the local team, and to start by Philippe Garnier, please.
Thank you, Mr. Chairman. Thank you for all the comments and remarks and questions that were very interesting, and I think we got some food for thought and continuation. I will not be too long, but first of all, I would like to thank very much Santosh for his work and its resilience, because it's the word, I would say, going to a certain external events. It's not so easy to perform at this level. Of course, there are still many questions, many opportunities for future for developing more research. We could not, and you could not, go into all the different parameters that will affect the quality of seismic bands and performance and understanding. But I would like just to emphasize the fact that a very important point that is not necessarily new to your thesis is how the research can go back to the field. Because in fact, this research is directly connected with the field, but now there is a real challenge. It's the same case that we experiment in the past with IT, and it should be probably a research topic as well. But it's very important for all of us. That means I hope that we will have the opportunity to take the results and see how we can use it on site with communities, builders, the people that are doing things and so on. I'm not going to say much more. Just maybe one remarks about, but it's normal that you have somehow forgotten the earth materials is coming from a factory. That means we have the characteristics. It's industrial materials. You have the characteristic of the mortar. That means maybe it's the mistake of Crater to say, okay, it's there. You just take it, but we can go back to the information. That means I'm pretty confident about that.
So maybe that can be added as an
Exactly.
appendix.
This is what I was thinking. So thank you, and I give back the floor to the colleagues.
Thank you. Thank you, Philippe. And now, Florent, please.
Yes, thank you, Jean-Manuel. Thank you, everyone, for your review and your questions. And thank you, Santosh, for your presentation and your report. And so I would say something to you that it was a great pleasure to work with you during these years, because you are a really kind person, always good mood. And so it was really great pleasure to work in the cold with you. And you are really hard worker, very dynamic, efficient, and pragmatic. And so because of this quality, you was able to make incredible things, because, okay, you present this work, but actually he made other work on run earth, and he was always available to help his colleagues. And so, yeah, it was always very appreciated to have his help, and pleasure to work with you. Always serious with the protocol also. very important. Then I would like to answer to some remark that of the jury. Jean-Claude, one of your remark was about the comparison of concrete band and wood band. So I would like to complete a bit the answer of Santosh. That yeah, we could say that RC band are more efficient than timber one, but actually it's not so. The answer for me is not so simple, because we, as RC band, have one geometrical possibility, because okay, you put your plank and you cast the concrete and so on. For the timber, it's more complicated, because you choose the shape, you choose the size of the timber element, and how you link them together. And so actually, I think the geometry that we use and the size of the element can be really optimized. And so I think we can reach very similar performances with timber if we work on this aspect, actually. Because yeah, we test one thing and we saw that it was not efficient, even with a quasi-static test that I'm not sure you okay, you only regarding your remark, Jean-Emmanuel, on the kind, the type of clay that was used. Actually, yeah, because it's maybe because of my fault. We use the Najan blocks that you well know, and it was well known because of the Terroso report. And I'm not sure that maybe I said it very informally to Santosh that it was okay with the clay, and we did not discuss about it. Actually, on the material topic, we went very quickly through this aspect, because we use industrial material that we knew that it was okay, and we used the mortar of the company because they knew that it was the mortar that was convenient with the block, and so it was one of the basis of our hypothesis. So all the material characteristic was not so developed. And last remark was that one of the main objectives of the shear test is the comprehension of the quasi-static test, is the comprehension of the wall, but not the wall structure, but yeah, to have a key point on the interface and on the shear resistance, and also it's a size that is convenient to be modeled. And then yeah, it's always necessary to, because actually it is not really precise here, but the other student performed a multi-scale approach, and this scale was absolutely necessary to carry on the model. And so this scale actually is very important and convenient to do parametrical study. And yeah, it's also better to have a full scale study. And so yeah, to conclude, so we are sad to let you go through the US, and we really hope to work with you one time. And thank you very much, and I wish you the best for your future project. Thank you, Santosh.
Can I just make a comment?
Yes, of course.
Yes,
Please.
So I always talk about the test, the in-plane test and the shear test, because there is this approach which has now continued for the past 30 years, that is sufficient to characterize masonry in plane, and that this is the behavior of a masonry structure. But that actually has very critical implications for the behavior in 3D. And then all our models, engineering models, to understand how building behaves are predicated on the assumptions that the wall will behave in plane. But that's not true. The walls behave out of plane. And there is very little research. It's more difficult to develop in the lab. I agree with that. But there is very little characterization of the actual out of plane behavior, which to a certain extent is. And we can see this in the, for instance, in the Eurocode. We can see this in many of the standards, which then affect the way in which we design and so on. So it's that, and in fact, it's that point that I'm trying to make. And in fact, it's very important that you have done the 3D dynamic analysis, because there you can really see how the structures behave and the relevant importance of the out of plane and in plane behavior, and the importance of the band to prevent that.
Thank you for this comment. Okay, the final word for your director.
Thank you.
Yannick, please.
So, I have no question for Santosh. I have already had many opportunities to exchange with him throughout his thesis. However, I would like to take this opportunity to provide some details on the work done with Santosh over the past several years. First of all, our collaboration started in 2017 when Santosh did an internship at the laboratory on the characterization of seismic band. This initial exploration work was essentially experimental and enabled us to know better each other. By mutual agreement, we decided to continue this work with a thesis the following years. In the meantime, we are writing a publication on the result of this internship, and which is very rare for master internship work. For my part, I was already convinced that Santosh was the perfect student to work on this ambitious subject to characterize the vulnerability of vernacular constructions. His seriousness, his ability to be autonomous, to find practical solutions, to be precise in his scientific approach, and his motivation was clearly here. At the same time, we developed a shake table at the laboratory to test the vulnerability of structures. When Santosh began his thesis, he worked very hard to finalize the development of this shake table. In early 2020, we were ready, and a lot of samples on masonry walls were going to be tested in March. Unfortunately, the February 2020 arson fire stopped at everything. I admit I was very discouraged in the first week after the fire. But Santosh did not give up. And he was able to help me bounce back to continue our work and move forward. We quickly looked for solutions to use another shake table. And thanks to the support of our university, we were able to set up in a record time a new experimental campaign, which another kind of break. Santosh worked very hard to set up this new experimental campaign, And together we managed to turn our misfortune into a great opportunity to test more ambitious sample than expected, house and radio scale. The rest, you saw it today through Santosh presentations. What you may not have seen is that we built 3 hours in, you said 2 weeks? 2 weeks, with a small team of few people. It takes willpower and courage to do that while learning to use specific measurements, means such as stereo correlations, in the evening at the hotel after the day of masonry work. This work is particularly important and goes far beyond a simple thesis on the vulnerability of constructions. This work shows that civil engineering researchers have an important role to play in helping our society to build the work of tomorrow in a more environmentally friendly way, but also to help a developing country to make the right choice at the reconstruction after an earthquake. We could have decided to study structures made with another material, such as concrete, which is considered to be more efficient during earthquake. We could also have chosen to reinforce the structures we have studied so that they are more in line with European practice. But we have never lost sight of the fact that our objective was to provide solutions that are relevant to the social and economic capacity of countries like Nepal, and not only relevant solutions in a mechanical way. Definitively, thanks to Santosh thesis works, we know now that seismic bands are relevant and efficient solutions. Of course, there is still of work to be done to ensure that the results are known and taken into account on the field, and that is what we must succeed in the coming months. I will end this speech by saying that it has been a real pleasure to work with you, Santosh, over the past few years. I wish every thesis supervisor one day the opportunity to work with a student like you, as bright as you, smart, valuable as you. Thank you, Santosh.
Thank you.
Okay, thank you. I don't know how we
will stay here.
We will stay here, and the people have to
Yeah.
go out, please.